Hello and welcome to the Unit 3 Section 5 video on the lines in the coordinate plane. So we have talked a bit in this unit about transversals and parallel lines and some perpendicular lines, and all of this can be plotted in the coordinate plane. So if we're going to plot it in coordinate plane, we need to talk about slope and the equations of lines. So we're going to have a little bit of a refresher on these topics. So the slope of a line is an indication of its steepness, okay? We read a graph from left to right, and there are four types of slope. You have positive slope, negative slope, zero slope, and undefined slope. Positive slope is when the line is going upward from left to right. Negative slope is when it's going downward. Zero slope is when you have a horizontal line, and you have undefined slope when it's going up and down. And the slope is undefined because we have no value for it. Because remember, we use rise over run to describe the slope of a line. So sometimes a vertical distance is called the rise, and then you have the horizontal distance referred to as the run. Well, when the run, which is the part in the denominator, is 0, you have division by 0, and division by 0 is undefined, and that happens when you have a vertical line. So that is why we say the slope is undefined. So here is a formal definition of the slope. The slope m of a line is the ratio of the change in y to the corresponding change in x. So we have change in y over change in x, and we usually indicate slope by the letter m. So here's an example on a graph. We have a line that passes through the origin and the point 4, 3. The change in y is 3, the change in x is 4, and so therefore our slope is 3 over 4. So let's do an example of finding the slope of the line on a graph. Well, let's pick a point. Let's say we pick this point here, and let's go to the next point where we go through, and that would be here. So we would have a rise of -1 and a run of +3. So our slope would be -1/3. The slope of a line can be determined when given the coordinates of the points are listed in a table. So here we have a listing of x and y values that correspond with each other. If you plot all these points, you get them on a graph like this, and you can plot a line straight through all of those points. The change between each set of coordinates is our change in y over change in x. So as long as you have two coordinates, you can determine what the slope of the line is. And you can do that using this formula. The slope of a line containing 2 points with coordinates x1, y1 and x2, y2 is given by this formula. M equals y2 minus y1 over x2 minus x1. Of course, we cannot have x1 and x2 be equal to one another, because if we did, then we'd have a vertical line, and we'd have an undefined slope because we'd have division by 0. So let's find the slope of the line that passes through the points -3, 4 and 8, -7. So we are going to do y2 minus y1 over x2 minus x1. Well, let's just make our y2 the first y here. That's 4. It doesn't matter which set of coordinates is your 1s and which one's your 2s, okay? And then we're going to do 4 minus -7 over -3 minus 8. So 4 minus -7, that's going to give us +11. -3 minus 8 gives us -11. So our slope is -1. For this other example, we can do -17. Let's reverse it. Let's make these are 2's and these are 1's. So you have -17 minus a -8 over negative 13 minus a negative 13. Well, we get negative 9 on the top, and we get 0 on the bottom, which means our slope is undefined. This means we have a vertical line. And you can tell that because our x's are the same. So that would indeed give us a vertical line. Our equation of our line would be x equals negative 13. All right, let's talk about comparing lines graphically. The graphs of lines P, Q, and L are shown below. Let's notice that the lines P and Q are parallel and L is perpendicular to the other two lines. Let's take a look at the slopes of these lines. So the slope of P, if you were to investigate it on the graph here, we have a rise of negative 1 and a run, or I should say rise of negative 2 and a run of 3. So our slope is negative 2/3. Our slope for Q is the same thing. We have negative 2 over 3, so we have a slope of negative 2/3. For L, we have a rise of 3 and a run of 2, so our slope is 3/2. So lines P and Q are parallel, and the slopes are the same. Line L is perpendicular to the other two lines, and its slope is the negative reciprocal. In other words, we have taken the slope of a line and we have flipped it from 2/3 to 3/2, and we've changed the sign, so it goes from being negative to positive. So these results suggest two important algebraic properties of parallel and perpendicular lines. So we have the parallel lines theorem. Any two non-vertical lines have the same slope if and only if they are parallel. So you'll notice the use of if and only if in this theorem. If a conditional and its converse are true, it can be written in if and only if form, which means it's a biconditional, meaning that we can say the theorem both directions and it would be true. So in other words, we can say two non-vertical lines have the same slope if they are parallel. We can also say if two lines are parallel, then they have the same slope. Okay? If they have the same slope, then they are parallel. If they are parallel, then they have the same slope. It works both directions. We also throw in any two vertical lines are parallel to take care of the situation where we can't divide by 0. So let's take a look at example 4. We're going to use the slopes of the two lines to prove that they are parallel. Well, the slope of line 1, so let's say the left-hand line, if you investigate that on the graph, it's negative 3. The slope of line 2 is also negative 3, so therefore the lines are parallel. Now sometimes we aren't given a graph and we actually have to do the math out. So for the first one, we're going to take our points. We'll do 9 minus 6 over 0 minus 7. And that is going to give us negative 3/7. For the second line, if we do 7 minus 1 over negative 3 minus 2, that's going to give us negative 6/5. Well, these are not the same slope, so therefore the lines are not parallel. We also have a perpendicular lines theorem. Two non-vertical lines are perpendicular if and only if their product of their slopes is negative 1. Vertical and horizontal lines are perpendicular. That takes care of our other statement. So if we take a look at this, we want to prove that these are perpendicular, not parallel. So line 1, let's call line 1 the one that is decreasing. The slope of that line, if we investigate it, is -2. The slope of the increasing line is 1/2. Since these are the negative reciprocal of one another, if you multiply them together, you would get -1. So therefore, we know that the lines are indeed perpendicular. All right, let's take a look at an example where we don't know the graph. So again, we're just going to plug it into our slope formula. Let's do -2 minus -1 over 0 minus 5. That's going to give us -1 over -5, which is 1/5. And then for the other one, let's do 5 minus -5. And let's do -1 minus 1. That's going to give us -10 over 2, which is -5. So these are the negative reciprocal of one another. The lines are perpendicular. So we've looked at this in terms of a graph. Now let's look at this in terms of the equations of lines. The equation of a line can be written in many different forms. One such form is slope-intercept form, which is y equals mx plus b, where m is our slope and b is our y-intercept. The x-intercept can also be found by substituting in 0 for y and solving for x. So let's find the slope, y-intercept, and x-intercept of this equation. So the slope is easy because all we have to do is pick out our m. So m equals 4. Our y-intercept is just as easy because we just pick out our b, which is 6. But for the x-intercept, we got to set y equal to 0. So it just requires a little solving. Subtract 6 from each side and divide by 4, and you get -3/2 equals x. So our x-intercept is -3/2. For example 9, we have to do a little bit of work on this equation to get it into slope-intercept form. So we have y minus 4 equals 5 times x plus 6. The first step is to distribute. And then we're going to add 4 to each side. Now we have it in this form. The slope can easily be found as 5. And the y-intercept can easily be found to be 34. To find the x-intercept, we set y equal to 0, and we get -34 equals 5x. So our x-intercept is -34 over 5. In example 10, what is the slope, y-intercept, and x-intercept of this one? Again, we have to do a little bit of work to get it into slope-intercept form. So we're going to subtract 2x from each side. So that gives us 5x minus 3. And then divide each side by 5. That gives us x minus 3/5. So our slope is 1. Our y-intercept is -3/5. So now we want to find the x-intercept. Again, setting y equals to 0, we get x minus 3/5. Add 3/5 to each side, and we get our x-intercept, which is 3/5. All right, let's take a look at this graph to determine the equation of the line. So we need a couple of pieces of information. We need our slope, so that's going to be 1, 2, 3, 4, rise of 4, run of 1, so our slope is 4. Our y-intercept also happens to be 4, so if we put it into y equals mx plus b, we get y equals 4x plus 4. For example 12, we're going to determine the x-intercept of the line. Well, we can't see what it is on the graph because the graph stops before then. So let's find out what the equation is. So we have our slope of this line, which is rise of -1, run of 2, so -1/2. Our y-intercept is 4. So the equation of our line is y equals -1/2 x plus 4. Now to find the x-intercept, we just set the equation equal to 0. Subtract 4 from each side. We can drop the negatives, and we multiply each side by 2. We get x equals 8. So our y-intercept is 8. Now there are two given scenarios in which you'll be asked for the equation of a line. If you're given the line slope and one point that the line passes through, or if you're given 2 points that the line passes through. So let's see how we solve for both of those situations. For example 13, we're going to write the slope-intercept form of the equation of the line whose slope is 1 and goes through the point 2, 5. Well, what we're going to do first is we are going to use y equals mx plus b to find out what our b is. So we're going to plug in 5 for y from our point. Our slope is 1. Our x is 2. And so now we just have to solve for b. So 5 equals 2 plus b, so b equals 3. Now we know what our b is. We can go back and plug in our slope, which is 1. And our b, which is 3. So we get y equals x plus 3 as the equation of our line. All right, in example 14, we're going to use slope-intercept form to write the slope-intercept form of the line that goes through the points that are presented here. So first we're going to find the slope using the slope formula. So we've got m equals, we're going to do the difference of our y's, which is -1 minus 4, over our difference of our x's, 1 minus -2. And so we end up with -5 over 3. Now we're going to use the slope in one set of coordinates to find the y-intercept. So now we're basically doing a problem like the one we just had. So we start with y equals mx plus b. Our y is going to be, let's just pick the first coordinates here, 4. M is -5/3. X is -2. And then you have b. So -5/3 times -2 is going to give us 10/3. And what I'm going to do is go ahead and rewrite 4 in terms of something over 3. 4 is the same as 12 over 3. So when we subtract 10 over 3 from 12 over 3, we get 2/3 for our b. And now we're going to take y equals mx plus b, and we're going to insert our slope, and we're going to insert our y-intercept. And that's our equation of our line. Now we did this with slope-intercept form, there's also another form called point slope form, where if you have a point and you have the slope, you can easily find it in 2 steps. So if we have 2 points, which again are the same 2 points that we used before, we're going to first find our slope, and this is just a repeat of the problem before. This looks exactly the same, at least this part of it does. -5/3 was our slope. But now instead of having to find a y-intercept, we can just use this formula to directly plug in. So y minus y1 equals m times x minus x1. You'll notice that this is very similar to the slope formula. That's because if you multiply each side by the denominator of the slope formula from the right-hand side, you will get point slope form. So we're going to keep that y the same. We are going to use one of our 2 points for y1. So we're going to use 4 from this set of points from the first set. We've got our slope, -5/3. We've got our x, and we've got our x1, which is -2. So now we've got y minus 4 equals -5/3 x. And then we've got -10/3 because this is x plus 2, so -5/3 times 2 is -10/3. And again, I am going to rewrite 4 as 12/3. So everything's in terms of thirds, so that when I add it to this side, I more easily get -5/3 x plus 2/3. And you'll find that this is exactly the same as what we got before, -5/3 x plus 2/3. Just a little bit more streamlined process in doing it. Notice that the second method only took 2 steps instead of 3. Also, because of the relationship between the slope formula and point slope form, you only have to remember one formula to do it this way. So let's recap a little bit. Forms of the equation of a line. You have point slope form. An example of one that you may encounter, y minus 3 equals 2 times x minus 4. You notice that we've got something to distribute. That's what it's going to look like. We have slope-intercept form, which is going to have y on one side and then something like 3x plus 6. In the equation of a vertical line, it's going to be x equal to some value. So let's say x equals 5. And for horizontal line, y equals to some value, which would be something like 2. In a horizontal line, the slope is 0. In a vertical line, the slope is undefined. Now let's compare lines algebraically. So we're going to pull geometry back into this and start talking about parallel and perpendicular lines again. So recall, parallel lines have the same slope, but they have different y-intercepts. And perpendicular lines have slopes that are the negative reciprocal. Knowing this, you can write the equations of lines that are parallel or perpendicular to other lines. So in example 16, we are tasked with writing an equation for a line that is parallel to the equation given and passes through a specific point. So first, we need to find what the parallel slope is. Well, that's easy because the parallel slope is just the slope of this line that we're trying to find that's parallel to it. So m equals -1. So since we have the slope and we have the point that the line passes through, all that's left to do is to put it into point slope form. Or so you think. Let's do that first, okay? Y minus y1 equals m times x minus x1. Well, y1 is going to be 8. Our slope is -1. we have x minus, and our x1 is 0. So we end up with y minus 8 equals negative x, so y equals negative x plus 8. Well, notice here, this is a y-intercept, right? So we have the slope in the y-intercept. We could just put it into y equals mx plus b. And then we just put our slope in, negative 1, x, and then our y-intercept is 8. And that would have been much easier and much faster. So it's worth knowing the information that you are given. If you recognize this point to be the y-intercept, then you'll probably want to use slope-intercept form. If it's not the y-intercept, then point-slope form is more likely the way that you want to go. All right, example 17. We're going to write an equation for a line that is perpendicular. So first we need to know what is the perpendicular slope. Well, the perpendicular slope is the negative reciprocal, so it's going to be positive, and it's going to be the inverse, so our perpendicular slope is 2. This point certainly is not a y-intercept, so our method will be to use the point-slope form. So y1 is 3, slope is 2, and x1 is 4. So now we just distribute. So we get 2x minus 8, and then we add 3 to each side, and we get 2x minus 5. And that's our slope for the line that's perpendicular to the one that they give us. All right, example 18. Let's write an equation for a line that is parallel to the one given. Well, there are no y's here. So let's take a look at what that means. Well, if we combine our x's, we get negative 3x equals 9. And if we solved for x and divide each side by negative 3, we'd get negative 3. Now, if we want a line that is parallel to this one, well, we know this is a vertical line. So they know that our parallel line equation has to be a vertical line as well. So it's going to be x equals something. Well, it's got to pass through this point. And so what does x equal at this point? It equals negative 8. And so that is our answer. X equals negative 8. That is the parallel line that passes through this point. That is vertical, just like the line that it's supposed to be parallel to. For example 19, we're to write an equation for a line that is perpendicular to negative 9x minus y equals 9 and passes through the point 0, 4. Well, first of all, let's rearrange this equation and get it into slope-intercept form. So we're going to move the 9x to the other side, and then we're going to multiply everything by negative 1, and that will flip the sign of everything. So our perpendicular slope is going to be m equals 1/9. Now, we have our slope, we know our point, and this is a y-intercept. So let's use y equals mx plus b. So our slope is 1/9, and our intercept is 4. And we have successfully written the line, the equation for the line that's perpendicular to the one that they gave us. All right, finally, number 20, example 20. We're going to do an application problem to wrap this up. So the population of Troy was 150,000 in 2010. And then it was 225,000 in 2020. So first we want to know, what is the rate of change for the population of Troy? That is, how much does the population change in 1 year? So we are going to do this using slope. So let's say that our years are our x1 and our x2, and our populations are our y1 and our y2. So we would do 225,000 minus 150,000 over 2020 minus 2010. So that would be 75,000 over 10, which reduces down to 7,500. So our slope is 7,500. So how does the rate of change relate to the slope of the line? Well, the rate of change is the slope of the line that relates population and time. Our rise would be population, and our time would be our run. So, knowing this, what do we think that the population of Troy will be in the year 2030? Well, we can use point slope form to figure that out. First of all, our Y1, we're going to use 150,000. Our M is 7,500. And our X1 is going to be 2010. Okay. Now, let's get this into y-intercept form. So we have 7,500x minus 15,075,000. And again, you can use your calculator for things like this. So y equals 7,500x minus 14,925,000. Now that we have this form, we want to know about the year 2030. So we're looking for y because y is our population. We're going to put 2030 in for our year. And when you crunch all of these numbers and do all of this math, you're going to end up with y equals 300,000. So a word problem requires a word answer. And so we would sum this up by saying the population is projected to be 300,000 in the year 2030. All right, this wraps up section 3.5, one of the longer sections of this unit. The next section is going to be about line constructions, and that will be the last section of the unit before we move on to triangles in Unit 4.